Hello.
Hello, uncle.
Hello, Krishma. How are you?
Good.
Okay. So when is the final exams for you?
Our final exam, uncle, it started. Tomorrow is maths.
Oh, okay. Already started. Okay. So how the
Yeah.
preparation going?
Yes, uncle, going good.
Going good. Okay. So do you have some problems or particular topics in maths for the exam tomorrow?
Uncle, last week you asked me to try to prove
Ah,
the.
okay. Okay. I remember that now. But okay, we can do that. Did you try that?
I tried it, uncle. I thought we have to do. We have to prove that it's congruent, but then I do not think that's the way.
Whi- which way you tried?
I thought first we have to prove that the two triangles are congruent.
Okay. So, but it went to 1 second. Let me take the whiteboard. Uh, so eventually, the whole thing, the discussion about we extended the possibilities of checking the whether our answer is right when we find the a particular coordinate points reflected by a line, straight line, right?
Yes.
And it
Yes.
went all the way to a proof of like we have been taught like a circle, and if you have a from the center, if you draw two radius, okay, and there will be an angle sus suspended in between, and the 2 points where they meet, if we go and connect it to the other side, make it like this, then they they make an angle there, theta.
Yeah.
This angle will be twice the theta. So this has been told, but I was just checking with you. I mean, anything can be proved, right?
Yes.
What mathematics is, it's not simply somebody said so we follow it. Uh, so you went for congruent triangles and everything, but it is a. So what happened? I mean, it's just, I mean, we have the property of the circle to be used and get this thing done, right?
Yeah.
So how to think very straightforwardly what is available, and from there can we go about and do things with that.
Okay, so if this is 2 theta, the other exterior angle will be 360 minus 2 theta.
Why is that? Oh,
Because the circle,
okay. This angle you are saying.
yeah, yeah.
Okay, why the thought process going about this angle?
Uh, I thought we can prove it by telling angle, I mean, the angles in a five-sided polygon will be equal to one.
Ah. You see, okay, I get that, but is this using the properties of the circle?
No.
So that is that itself, because this cannot happen for anything like you take any point and draw, like without the circle, if I draw 2 points somewhere and then connect it anywhere, this is not going to happen, right?
Yes.
So the circle property has to be involved. Otherwise, we are not. This is not possible when the 3 points, the exterior 3 points, and the in between point is all that. This is the center, and then the other 3 points should lie on the circle. Do you get that? That is very
Yes,
important.
sir.
So then think about how the circle property has to be included in the proof. You see, even the thought process has to be fit through some kind of rationale behind why we are thinking like that, whether that has considered everything that has to be used to solve the problem. Do you see that?
Yes.
This is very important. So our thought process should include everything and concerned about if we don't use the circle property, then we are not solving this problem. Do you get that?
Yes, sir.
And only the circle is holding that the whole reason why this is theta and why is 2 theta. Look at the picture carefully and look at it and think about involving the circle. First of all, what is the thing you see straight away from the circle here? There are one, two, three, 4 lines are there, right?
Yes.
In the 4 lines, what is straight away connected to the circle?
The 2 radii.
Okay. There are 2 line segments of the 4 lines. So we are saying that this is a R and this is a R. Do you see that?
Yes, sir.
Okay. And now, okay, with this, start thinking further what could be extended, because this 2R is only connecting 3 points, the center and the 2 exterior point, which is on the circumference, which is on the circle. How about the third point? Think about how to include the third point. With this, that should involve the circle property.
Yes, uncle. Like we can join the 2 lines. We can join.
Another radius can be like this.
This will be R.
Now, you see how the thought process has to be fueled in such a way we are making use of the circle property. Now we have lot of things to think about, talk about, make use of. Now, using the 3 radii, what else you see here?
And it forms isosceles triangle.
You see there is an isosceles triangle and 2 symmetric ones. I mean is this one, for example. Now you see that the angle you thought about now coming into picture in a different way. Do you see that?
Yes, sir.
These 2 angles are the one you summed up and say that it is a 360 minus 2 theta or something.
Yes.
But rather start the problem like, okay, these 2, as it is an isosceles, both of them are isosceles triangle. Let's say if this angle is going to be some angle and this angle, they have to be equal angles. Do you get that?
Yes.
Okay, and they have to be equal angle this also, same angle here.
Yes.
Okay, so that is actually making whatever this angle, call that as say theta. I would take it as a theta by 2, for example. Is that okay?
Yes.
Theta by 2, and this will be a theta by 2, and the whole angle will be a theta. Is that okay?
Yes.
So now what else?
Okay. So
if it is theta and theta by 2, and what will be this whole angle? This angle will be what, first of all?
That will be 180 minus theta by 2 plus theta.
That will be 180 minus both this, minus theta by 2, right?
Yeah. Yes.
So that will be minus 3 theta by 2, isn't it?
Yes.
And this angle will also be the same, isn't it?
Yes.
So this will be 180 minus 3 theta by 2. So what will be this angle then? Because it is the center of the whole center angle. That is, this should be simply 360 minus twice that angle. Do you get that?
Yeah. Yes.
That will be twice 180 minus 3 theta by 2. So that will simplify to 360 minus 360 plus. Somewhere we made a mistake. What is the mistake we made? Because this comes to 3 theta.
Okay.
Okay. I know this angle, even though the whole angle is theta, this angle is only theta by 2. Do you get that?
Oh, okay.
Isosceles. So this should
Yes,
be 180 minus 2 theta.
Yeah, 180 minus 2.
Minus 2 theta. That's the mistake we made. So this is also 180. So I would use the eraser rather. We have to be careful. My diagrams are very crooked here. So then we made a silly mistake here because I wrote it as a theta, but actually it is theta by 2, theta by 2.
Yeah.
So it is minus theta and minus theta. And here also this should be right.
Yeah.
Okay. So this has to be minus theta.
Theta. Yeah.
Yeah. So
then
this
it comes. Yes.
by 2 theta. It's not a very difficult problem, but only thing is how from the beginning the thought process should go to this cannot be possible if it is not the 3 points and the fourth point is a center, the 3 points are lying on the circle. That then automatically the property of the circle has to be used somehow. Then your thought went to that right direction, that already the two segments or line segments are radius, and then the third one can be from the center to the third point to be included, and then the isosceles triangle. You see, the thought process is all chained one after the other. It's popped up, and then the problem is simply solved. Do you see that?
Yes.
Okay, so that is why when we have to fuel our thought process using considering everything what is involved in the problem, and we have to check whether the main things are included in the problem. Otherwise, we are going somewhere totally in a different angle, and that is not going to be helping us to solve the problem. Even though we will be working out something, I'm not against that, but we need to also process our thought process and something connected to that. Otherwise, we will look like an insane person. Do you see that? We should not, we should be relevant with the context, and we should think tangentially without jeopardizing the original main thing about the thing what we are talking about or thinking about or working about. Okay.
Yes.
Okay. So that's okay. I mean, so do you have any problems what you are working for the exams? You find any topic or any problem which is not provoking your thought process in a way that that leads to efficiently to the solution or handling the steps or something like that?
Uncle, the geometric progression question.
Okay, GP. Okay, geometry
Yeah.
series, right?
Yes, sequences and series.
Okay, so next page. So the sequences series are one of the important math concept. Okay, I mean there are two types: the arithmetic and then the geometric. As you asked straight away to the geometric, well, let's go to the geometric series. Okay, so okay, I mean only in India I heard this word, the progression. Okay, but the more globally used words are sequence and series. Okay.
Okay.
Sequence is writing the terms. Series is adding them. Okay. So that's
Okay.
make the difference. For example, if we call that it is a A1, A2, A3, and we keep going up to AN, then it is a particular n terms are there, n number of terms, and we are going to say for that sequence, there is a interesting thing is about if you add them up, what will happen? So that's the question we will be interested. So all these things are connected back to when we try to make mathematical modeling of any phenomenon or any system or anything like that. It will mostly involve calculus, and then the calculus also sometimes we may not have a very beautiful function to straight away differentiate or integrate or something like that. So in that case, there is a very important series called Taylor series will come into picture. And the Taylor series, mostly it will involve the geometric series. That is addition of, and mostly it may even involve up to infinity. So the series, so this is so defined a finite number of terms. Do you get that? Finite number of terms and number of terms. And the series could be infinite also. So we could have all these things, A1 plus A2 plus A3, add them up, and keep going. There could be a nth term and keep going up to infinity. So sum of infinite terms, sum. Okay. It may look straight away, it may, how come if you add infinite terms, that should be infinity, right? It looks like that.
Yeah.
But particularly in the geometric series, the geometric series, there is something called important property called whether it is converging or diverging. Okay. Converging or diverging. What that is, first of all, geometric series itself, meaning, let's say I have a first term, we call that as normally a, and then the second term is a fixed ratio multiplication of the first term will lead to our second term. Do you see that?
Yes.
So basically we are saying that is, okay, then the third term will look a r power 2. Yeah, it will go like that. So a r cubed, and it can go to a term. Let's say, okay, I mean, I put the series and I did not put the series, means we are already talking about the addition. Okay. So
Yeah.
sequence means only we are putting a comma, and so this is what I was talking about, and it can go up to our a r power. Now you see here there is a r also available, but the power is 0.
Yes.
You see that, and this is actually a r power 1. So we normally call that this is the n equal to 1 term. This is the n equal to 2 term. You get that? First term, second term, that is what I mean. Do you see that?
Yes.
N equal to 3 or something like that. So when you look at the n number and the power of the r, then definitely if this is our n equal to n term, then we have to write the power for the r as n minus 1. Does it make sense?
Yes.
Because it's the nth term and the r.
Yeah, it will be n minus.
N minus 1. Okay, so that can also, this can go up to infinity also. So here, one thing what we need to understand, there is a common a is multiplied with all the terms, and every term is getting a extra one amount of r factor multiplied. So property of the sequence or the series is decided by two things. One is the a and another one is the r. Right? So when it comes to any sequence given to us or series given to us, first of all, we need to make sure that it is a geometric series. What I mean, let's say there is something like, 2, 4, 6, no, 2 times, this is, I'm just taking both of them are becoming 2, right? So this will go like, 8 to 16, it can go
8
like
and
that.
16.
Yeah, for example. So we need to check that. So take the 4 by 2, then it goes to 2. 8 by 2 also, 8 by 4 is going to be a 2, and the 16 by. So make sure that we are working on a series which fits into a category. Then only we can work further on that. So we made sure that. So because of that also, we have found that A is actually our 2 comes from here, the very first one. And then the R is going to be our 2 as well in this case. So the AN can be written as, in this particular problem, 2 multiplied by 2 power n minus 1. Do you get that?
Yes.
So this can be also simplified as 2 power n is going to be our the nth term itself. Is that okay?
Yes.
So when you plug in the n value, we can find, let's say I want to find the 10th term or something like that. A10 will be 2 power 10. That will be 1010, if I'm not wrong. 1010. Okay. This is our 2 power 10. Is that okay?
Yes.
Okay. And then when it comes to the summation, That is the adding up n terms. Let's take it for the, okay, I mean, I still not mentioned about the, so this R value. So the R value, so we have the,
Uncle, won't it be 1024?
Okay. Correction factor. Okay. You are right. So 1010 is, yeah, that is actually our 10 equivalent to 2 base. Okay, that is where I got the, so 10 in the base 10 is equal to 1010 in base 2. That has made me to make this mistake. Do you see that? Where the,
Okay.
You know the base 2 binary number system, right? You know this, right? The decimal.
No.
You don't know binary number system? You have not
Oh,
studied number. Yeah.
no.
Hmm,
Log, yes, but not.
very, very strange. You are already in the 11th standard, right?
Yes.
Very strange. What happened to our curriculum? Even I studied only in the state board. Like we studied number system in the 6th
I know
standard.
what are binary numbers.
Yeah, but binary numbers is one of the system, right? What we commonly use is called the decimal number system.
Yes, uncle.
So
no, we have not learned binary.
Yeah, in general, we are going to have a number system that base could be anything. So it could be base n in general, right? So that is what we learned. What is the meaning of base n and how to make any base n number system? All those things we studied around the 6th standard, actually, of your age.
Okay.
Okay. Anyhow, let's move on with, so we have this, we call the common ratio, right?
Yes.
Common ratio. So that is actually when you take the a power n plus 1 and divide by a power n, that will be our R, isn't it? So if you find that this R is going to be, it could be either positive or negative, doesn't matter. Let me write it as -1 less than or equal to, not equal to, less than or less than 1. Meaning, if it is a fractional quantity, it doesn't matter which direction it is. So if it is a fractional quantity less than 1, then what? Let's take an example case. Let's take an example case as R is actually equal to 0.5, right?
Yes.
So this fit into this particular condition. So, and also take this is an example case. We are saying example 1 and take the A to be a 1, for example. We can make a sequence, geometric sequence or a geometric series. Let's write it in a sequence. Then it will be 1 and it will be 1 by 2 will be the next term. Do you get that?
Yes, sir.
The next will be 1 by 4 and the next will be 1 by 8.
1 by 8.
It goes
1 by 6.
and it goes, keep going down. Do you get that? Every value is going down.
Yes.
It will go down, and any term when we are as it is going to be our half. So this is going to be an. Let's calculate the an. An is going to be our a r power n minus 1. That is going to be 1 multiplied by 1 over 2 whole power n minus 1. Is that clear? Is that okay? So this is 1 over 2 power n minus 1. So the nth term will look like 1 over 2 power n minus 1, and it keep reducing. Do you get that? So at some point it will converge to a value. Most likely this one will asymptotically it is going to 0. Do you get that?
Yes, sir.
We keep on dividing. Asymptotically, it goes to 0. So this kind of series, we call that it is converging. Okay, this is converging because of the R value lies in that, converging. So this kind of series, even if you take infinite terms, they will all add up and it will give you a finite sum. Does it make sense for you?
Yes, sir.
Okay. And also, if this is not satisfied, this condition is not satisfied, if they R is either greater than 1 or in the positive direction or greater than 1 in the negative direction also, it will be a diverging one. It will be keep increasing one after
Okay.
that term. Okay. So let's take the interesting point. So exam problem could be, they may ask whether the series is converging or diverging or finding the nth term and all those stuff. I think you can do that,
Okay.
right?
Yes, sir.
Okay. And now let's go to the summation. Let's call I'm interested in adding up the S is actually equal to, I start with the infinite series, which looks like A plus A R power, no, A R power 1 plus A R power 2 plus,
2.
it goes on. Let's say even we have the term like, okay, let's start with the AR power n minus 1. Is that okay?
Yes, sir.
Okay. So the clue is each term is getting multiplied with R. So if you look at the consecutive two terms, only the R multiplication is the difference, right?
Yes, sir.
So that is giving us a clue. Let's multiply this whole equation by a R. That means RS will be equal to, each term will be multiplied. I write it one shifted away because this A multiplication will yield this. Do you get that? And this
Yes.
AR squared. Do you see that? This would have
Yes.
produced this, and then this would produce a AR cubed. It goes like that. And when you go all the way, the previous term would have produced our AR power n minus 1. Do you get that?
Yes, sir.
And then this would produce a AR power n. This
N,
particular one would have produced this one, just for understanding. So here we have a, if you want, we can add that AR power n minus 2 term would have produced the AR power n minus 1. Does it make sense?
Yes, sir.
Okay, so what it has made us, the difference between the two equation is simply all of these are, except the first term in the S and the last term in the RS, in between terms are exactly the same. So if you call this as equation 1 and call this as equation 2, if I take the equation 2 minus equation 1, this will include left hand side will look like RS minus S will be equal to AR power n minus A. Is that okay? All other terms?
Yes, yeah. It'll get,
yeah. Now we can factorize the S. That will leave us
R minus 1.
R minus 1 equals, here also A can be factorized.
R power n minus
1. We want the S. S is actually A times R power n.
R power n minus 1 by R
minus 1. We can actually multiply and divide by minus 1. This can also be written as both are equal. A 1 minus R power n.
1 minus R power n by
1 minus R. So even we have proved this, and applying this also should be straightforward, because as long as carefully checking that the sequence is going to be our geometric progression or whatever the series, then if you carefully calculate the A and R, and if you know how many terms we are going to add up, so knowing the value of A, R, and N, we can plug it in and we can tell the answer as what is the total sum of the series. Is that okay?
Yes.
So you get problems like that, right?
Yes.
So let's complete the other one where infinite series is involved, and if it is converging, let's write it like that will look like, so infinite geometric series and converging. That's important. Okay.
Yes.
So converging means we have to check that condition that minus 1 less than or less than 1. Whether if this is valid only, what we are going to do is Fine, because we are going to say that we are interested in S is equal to A plus AR plus AR power 2 plus it goes on, and we are going to have I'm going to I mean it is going to up to it is going to infinity, but as it is converging, and also it is going to become zero at some point. Do you get that?
Yes.
Okay, it is diminishing and going to zero. It doesn't matter, as long as we go up to infinite terms, somewhere it is going to infinity. And also do the same thing. So the R is going to be multiply with the R will yield us AR plus AR power 2 plus it keeps going. Do you get that?
Yes.
And it will also go to infinity, but it will go and diminish and gone to zero at some point. So do the same thing. Call this equation as a 1, call this equation as a 2. 2 minus 1 will yield us
Only
RS is actually equal to A. A will okay, minus minus
yeah, RS minus.
minus S will be equal to simply the A will survive.
Yeah.
If you factorize the S, R minus 1
R minus 1
is equal to A. So S is equal to A over R minus 1. So here, no, it's a mistake. We should have subtracted 1 minus, because this is wrong. We cannot get this. Do you see what I'm saying? Because the first one has the one extra term. So we should have subtracted.
Oh, right.
Yeah, we should have subtracted 1 minus 2 would yield S minus RS, that is A. The previous subtraction should have yielded a minus A. Actually, I corrected everything. I was rushing and you are not correcting me. I want to blame you. S is actually equal to A over 1 minus. You know why I found this mistake? Because the R is a less than a 1 quantity. When I put the denominator as R minus 1, I know that it's going to be a negative value.
Yeah.
You see that? So
yes.
that is how our thought process, looking in and around about any problem that should give us. Okay.
Yes.
So, any questions?
No.
And also for the infinite series, we need to know only the A value and R value. We need to check two things. Whether, first of all, it is a geometric series, and then whether the R value is diminishing less than 1, then we are good. We can easily solve the problem for that. Is that okay?
Yes.
Okay. So when you get the questions, is there anything concept-wise, anything missed out about the geometric series?
Arithmetic mean and geometric mean we have that first.
Okay, so you have arithmetic mean and geometric mean. Okay, so what they do with that? So how they calculate? Mean is actually average, right?
Yes, sir.
Mean means always the word we have to understand as average. So let's say if you have n number of terms, then we are looking for adding up and dividing by the number of terms. That's what the average is.
Yes.
Okay. So basically, if it is an arithmetic series or geometric series, if you know how to add the n number of terms, then you know how to divide that value by n also. That is what it is, right?
Yes, sir.
So what I mean, so we can call that, okay, I use the letter, I don't know what they use. Sometimes when we call they are all going to be AI, right?
Yes.
So we can say that because this is going to be our series where I is going to be 1, I is going to be 1, 2, 3, going up to n, right?
Yes.
So if you want to find the average, we call that as A bar is the letter people use, or sometimes people use the mu also. In statistics and everything, we use the mu. All we are saying is 1 over n, that is the number of terms we added, summation of I running from 1 to n ai. Is that okay?
Yes.
So let's say the ai is a geometric sequence. So the terms A1, A2, A3, they fit into a geometric one. Then we can calculate we know that the summation I running from 1 to n, ai is going to be a multiplied by 1 minus r power n divided by 1 minus r, isn't it?
Yes.
Now we can plug in there and get that. So this has to be plugged in, and you have to take that value. Don't forget to divide by n. That will give you the geometric mean of a given sequence for n number of terms. This is how they calculate, right?
Yes.
Okay. So
yeah, for arithmetic, one second. For AP, they told that the mean.
yeah, but arithmetic series is completely different. So we need to look into how to add them up, and everything comes as a different. But we cannot just use the terminology word. Okay, both are means, and we have to follow the same procedure. Not like that. The concept is mean is simply the data. For example, if you know some 100 people height, then if you want to find the mean height or average height, then add all the 100 heights and divide by 100 will give you the mean. So that should be the understanding of what we talk about an average or a mean. Now, when you come to a particular case, like it could be heights or it could be some data, all we need to do is add them and divide by the number of terms or number of data. But when the data itself falls into a particular category of arithmetic sequence or a geometric sequence or something like that, then we need to use the property of the geometric sequence, what is happening and everything. We need to generate the sum of the n number of terms. Do you get that?
Yes. Yes.
So when you go to arithmetic, we have different type of arithmetic. Like in the geometric, we have converging one and diverging one. In the arithmetic one, we have like arithmetic sequence. This itself can be split into different categories. So first one could be linear, and it could be quadratic. You get that?
Yes.
And it could be cubic. So it can be any polynomial, it can be. So it could be quad. And it could be quintic, right? So what I mean, when you have what is the main difference between the geometric and arithmetic? Arithmetic is, let's say, if you have a first term and the second term is a added with a difference. Do you see that?
Yes, sir.
Then instead of multiplying the common ratio, here we are going to add the difference. That is what this is going to be. So now if you look at here, so the nth term so this is going to be our a plus d power 0. I mean, this is actually 0 multiplied by d. Do you get that?
Yes.
And this one is a
1.
Plus 1 multiplied with d. But we know that this is a n equal to 1 and this is n equal to 2, like that. So when you go to the nth term,
a plus n minus 1.
Yeah, a plus n minus 1 d, and this is our nth term. Okay. This is our n equal to n. So when you see that, like the n looks like our running variable. Do you see that?
Yes, sir.
So this is just n multiplied with the d. So this looks like if you take any two terms which are having, if you know how many number of terms, the gap between those, then easily we can straight away with the linear thing, we can find it. What is the meaning? I just write it as, let's say A, okay, let me, A plus D, A plus 2D, A plus 3D. It can keep going on, A plus 4D, right?
Yes.
And I will go for the first order difference. Okay, first order difference is I subtract A plus D minus A, I will go directly to D. So all these
D, yeah.
subtractions straight away, it will go to D.
D, yeah.
So when the first order difference itself is going to be the same value, so this is a constant, then we call that this particular series as, this series fit into linear arithmetic sequence. Okay.
Okay.
Linear arithmetic sequence. Why it is so? It fits straight away. Like we know the sequence and we made the common difference, and the first common difference itself is a constant D. Then take a sequence like 3, 8, 13, it should be 18, right? 18, 23, like that. Then just look for the difference. So the common difference, we are going to say 5, the 5. Do you see that? 5,
Yes.
5, 5. So this fit into linear arithmetic sequence. Okay. So now with this is easy. Like we know that the nth term can be calculated by A plus n minus 1. Even we can put A1 actually. A1 plus n minus 1 into D. Does it make sense? Is that okay?
Yes.
In this particular case, we are saying A1 is going to be our 3 and D is going to be our 5. All fits into this thing. And sometime it may, even the general thought process should help us to process this. How to process this? We know that only 2 parameters are defining the whole sequence, the A and the D. So we know that the A1 is actually equal to the A1 plus 1 minus 1 multiplied by D. So this will simplify to A1 itself. Do you get that?
Yes. Yes.
So the A1 and the D, those two are the 2 terms we need. So we already, when we look at here, we know that it is going to be our 3 itself. And we have another unknown, D. So we need to go for the second one that will help us to solve the problem. This will be A1 plus 2 minus 1 into D. That will simplify to A1 plus D, which we know that this is the second value. Do you see that?
Yes.
So this will help us. D is nothing but 8 minus A1, which is going to be our 5. 8 minus 3 is a 5. This is very normal thought process, will lead us to solve the problem and get this thing done. Do you get that?
Yes.
Okay. Okay. I don't know whether you studied the quadratic arithmetic sequence.
No, uncle. We had only linear.
Okay. Let's see whether I will. It's not a difficult thing, but we can talk about that later. We should be interested in adding this up, right? That is a problem we have. So the sequence, the AN is actually looking like, I write the first one as a A itself, A plus n minus 1 into D, right? This is what we have. So let's say we want to add this, like let's say we want to add the sum of all the I equals 1 to n, right?
Yes.
Or we can say that because we used the n, let's call that n equal to 1 to capital N. Let it be, right? So an, this is what we are interested in, isn't it?
Yes.
Okay. So the proof is included, or they give the formula straight away for you?
They gave the formula.
So they never proved.
No.
How about the geometric progression? I mean, the series, the series. I just shown you how to get the.
Yes, uncle. No, that also they just gave the formula. Then we
They're given straight away the formula.
Yeah.
So they are not actually helping the students to have the thought process like why we are doing this, where it is going to be applicable, and why the summation is going to be a expression like that. That will increase the knowledge, right?
Yes.
I don't know. Okay, so what the formula they have given?
Sn. You're asking the sum, right?
Yeah, up
Yeah.
to number of terms. Yeah.
N by 2 into 2a plus n minus 1 into d.
N by 2 multiplied by
2a plus n minus 1 into d.
Okay, so in this case, I need to erase the way I have written because this should be because we are writing it lowercase n, so this should be I running from 1 to lowercase n, and it should be I. Is that okay?
Yes.
Okay, I mean, it's not a difficult one to prove, but anyhow, I mean, we don't need to look into that today. But you know this, and also they stopped it at linear arithmetic sequence itself. So now
yes,
you know that how to check it, first of all, whether it is linear arithmetic. If the first order difference itself is common, then that particular sequence fit into linear arithmetic sequence. And if you add n number of terms, then you need to know the first value and then the common difference and the number of terms you are adding. You can plug it into all those values into this equation and you can get it. And of course, you can find the mu, the common, the average, that this summation. So 1 over n, the same summation. Do you get that? I equal to
yes, sir.
n ai. So that will look like the n will get cancelled. So it will be, and off also, I mean, if you want, you can take it inside. So this will look like a plus n minus 1 d by 2. Is that okay? So
yes, sir.
This will be our average or the mean. This should be straightforward. So why you brought this? Which part made you to think like we can discuss about this today?
No, I didn't have the correct understanding about how the formulas came. That was one.
Okay.
I was finding it hard. And plus, there's one more sum which I was doubtful about.
Yeah, but so far you now you get the clarity about what is
yes,
going.
Yes.
In India, people even still calling the problems as sum. It's not everything is a sum. Sum is only addition is a sum. Okay, it should be problem.
Yes.
Okay, what kind of problem?
Uncle, can I send the question to you?
Yeah.
Uncle, in this, the 35th question.
Okay. It is downloading. So your marks for tomorrow, I mean, all these final exam, they are not accountable for your next year marks, right?
No.
Okay. Still downloading. Okay, 35th question.
35.
Yeah, between 1 and 31, M arithmetic means have been inserted in such a way that ratio of 7th and m minus 1th means is 5:9. Find the value of m. Okay, I mean, actually any given problem, we need to understand what is the information and what is available to us. Okay, so once we are with that, then it is good to go. So
Yes.
have we looked into that? So between 1 and 31, so the first value is a 1 and the last value is a 31, right?
Yes, sir.
That is what they mean. M arithmetic means have been inserted. Okay, so there is a M, let's say there are n number of them, but in the n, there are n number of terms between 1 and 31.
Yes, sir.
And m arithmetic mean have been inserted in such a way that the ratio of 7th and m minus. So okay, what they mean? Okay, so forget this. So let's take it. So they are saying that 1 and 31, right?
Yes, sir.
So 1 and 31. So the 1 and 31. So that means, is my understanding, there is arithmetic sequence and the first term is 1 and the last term is 31.
Yes, yes. Yes.
That is what they mean, right? This is
Yes.
A is a 1 and this is our A plus n minus 1 D, isn't it?
Yes.
Okay, and we don't know what is the n itself. So n and d both are unknown. Do you get that?
Yes. Yes.
Let it be. And they are saying that if you take a m and the mu 7 is to what they are given.
And m minus 1.
So first one is mu 7, right?
Yes, sir.
So what I mean is the ratio of 7th and m minus 1th is 5:9, right?
Yes. Yes.
Oh, okay. So this ratio mu m minus 1 is going to be 5:9, isn't it?
Yes. Yes.
That's it. So now the ratio, even though written like that, this actually meaning mu 7 divided by mu m minus 1, isn't it?
Yeah. Yes.
Equal to 5/9.
5/9.
Okay. And we know that mu for an arithmetic sequence is a plus n minus 1 times
n minus 1
by 2,
yeah.
Isn't it?
Yes.
Now, if you write mu 7, that is going to be a plus 3d.
Uncle, d by 2?
Yeah, that is what we got, right? We divide by n got cancelled, and then when you multiply with the 2 of, we divide by 2, a plus n minus 1 d by 2. That is what I have. What is the?
Okay, yes, sir.
Is that right or wrong?
It's okay. I thought it's just a plus n minus 1 into d.
That is the nth term, not the average.
Okay.
Double check that. I mean, this is average. We are talking about the average
okay,
of.
Okay. Yes, uncle. Yes.
Comes, right.
Yeah.
And then the mu m minus 1 will look like a plus m minus 1 that will be m minus 2 multiplied by d by 2. Is that okay?
Yes.
That's it. I mean, I just plugged in the information available into that, and that is how things go by. So that makes us, also we know that a is a 1, right?
Yes.
So this will be 1 plus 3d, and this will become 1 plus m minus 2 d by 2. Isn't it?
Yes.
Okay. So, okay, let's plug in into this one. Okay, so this will give us 1 plus 3d divided by 1 plus m minus 2d by 2 is actually equal to 5 over 9. Is that okay?
Yes.
Still, we have two unknowns. One is a d and one is a m. We need to make use of this 31. That 31 is going to be how that can help us. So that is going to be a plus. So that 31, let's put a line here. That says 1 plus n minus 1 d is actually equal to 31. Is that okay?
Yes.
Okay. So m minus problem statement is between 1 and 31. M arithmetic means
What they told in the solution was that seventh meaning it's the eighth term.
so each one is the sequence itself is an arithmetic mean sequence. It looks like that.
Okay.
You see the understanding. Let me go to a new page. Like it looks like they have 1 and 31, right?
Yeah.
What this means, 1 comma, the 1 itself is actually the mean of the first one only. We get that?
Okay, so it's an arithmetic mean sequence.
Yeah, so this is actually the whatever the previous term and add this one divided. So this goes as mu naught, mu 1, like that, mu 1, mu 2, mu 3. This is a sequence. That is
Yes.
what they call it as. You get that? It goes to up to some mu n. Okay, that is why they were saying that if you take the first 3, like the mu naught plus mu 1 plus mu 2 divided by 3 will give you the mu 3.
Yes.
So it is, this may mean the mean also will fall into a arithmetic sequence. Do you get that? By itself, this is an arithmetic sequence, but also they are filled with only the arithmetic mean, the mean values.
Yes.
So then what we progressed is not actually leading us to the. So the last one, okay. Then the last one, the nth term is actually this is also same as this one is the mean. This is actually mu of m minus 1. Is that right? No. Yeah.
Yes.
If yeah, m is the any general term, right? So this we can take this as the 31, right?
Yeah.
Okay, yeah. So this whole thing is actually going to be our 31. So this is going to be our 31. So that leads to 1 plus 3d divided by 5 by 9. Hopefully, I think this is not wrong. So this will be 9 plus 27d is actually equal to 155. So 27d is going to be 146. So we get a d, and with the d we can solve for the m. This is how they proceed. I can't hear you.
Uncle, they have got DS2.
DS2.
Yeah. They've taken it as a plus 7d is equal to 5 by a plus 7d by a plus m minus 1 into d is equal to 5 by 9.
Yeah, because we are trying to find the average of the arithmetic sequence, but the given sequence itself is the sequence made up of means. So that's why they went for the eighth term itself is the average of 7.
Yeah, yes.
And then they went for the last one, which is the average of the n minus 1 terms. So, okay, this one is correct, but where the 31 comes into picture. So the last term is 31. So they just used the a plus 7d over 31 here.
No, uncle. After that, they found d by using this. By using the first one, the a plus 7d by a plus n minus 1 into d is equal to 5 by 9. And they use that to find, yeah, the last term is 31. So it will be a is 1. So 1 plus m plus 1 into 2 is equal to 31.
But this last one is actually 31, right? A plus n minus 1d is 31. This is correct or not?
It should be, yeah, it should be.
It should be right.
Yeah.
This leads to, okay, this is not right. This one, I just take this here. So this will be 9a plus 63d is actually equal to 155.
Yes.
So 60. Okay, we know that a is a 1. A is actually equal to 1.
Yeah.
Because of that, 63d is actually equal to 146.
Yeah.
So then d is 146 divided by 63. No. If you remove, yeah. You said d is a 2, right?
Yes, uncle.
But why I get 146 in the numerator? Yeah. Did I make a mistake? 30, 150, 155. This is not giving me 2. 2 means numerator should be 126, right?
Mm.
70. Yeah, 9 times 1 is a 9. 9 times 7 is a 63d. That is all right. If you subtract 150 by 9, that will be 140. I don't find a mistake anywhere. Check the calculation, what you have. The solution.
Yeah, yes, sir.
Find the mistake where we are making the mistake.
Okay, so after that, they have done it as 1 plus 70 by 31 minus 2d is equal to 5 by 9. There's a 2d there.
So they are saying this is not right here. So they use here 31 plus
31 minus 2d.
So the beginning understanding itself is not correct, Karishma, here. Okay. We are progressing with a lot of things here, but like we are talking about a sequence and we are talking about getting the means of the sequence, and they are talking about 1 and 31. They are representing the relationship itself. We are not understanding it correctly. Do you understand what I'm saying?
Yes, sir. Yes.
So the sequence itself, okay, let's say the sequence, original sequence is of A1, A2, A3 like that. Let's say these are all falling into, let's say, take up to AN. Then using this arithmetic sequence, we could generate the mean of, like, there is a mu1, there is a mu2, there is a mu3, and it can go up to mu n.
Yes.
What this mean? What is the connection between these two? Mu1 is A1 by 1.
Yes.
Mu2 is A1 plus A2 divided by 2. Okay. And mu3 is A1 plus A2 plus A3 over 3. It goes on like that. And until we go to the last one as mu n is going to be our summation of all of them. I is running from 1 to n, whole thing divided by n.
Yes.
Okay. So they are saying that this is actually equal to between 1 and 30. So 1 and 31. So there is a sequence formed by this. You need to spend a bit more time on understanding why this is a 31 minus 2D.
Yes.
Okay, look into that. Okay, because
Okay.
I'm not, really catching up with because first of all, we need to have a good understanding of what is going right. That itself is, you need to read try to make sense out of that. We need to know exactly, we know separately what is a arithmetic sequence is. No problem with that. We know separately what is a mean of an arithmetic sequence is. Then a problem like this, they are trying to connect a sequence made with, something is going on. Otherwise, I don't understand what they write it as a 31 plus 2D. Right.
Yes.
So they are saying that this is our mu m minus 1.
I'll check on it.
Yeah, please check that, okay? And you need to read and try to make sense out of, without the meaning, just throwing in the numbers and getting a right answer is not increasing our knowledge. That is not going to help us if they are going to question different way. Do you get that? Only the understanding will help. So try to look into that and get clarified. And if you have any doubt, take image and send it to me. I can also help you. Okay.
Okay.
Okay. Okay then.
Yes.
Okay. All the best for the exams. Okay.
Thank you. Thank you.
Okay. Yeah. Bye.